All right, here we go. This one is actually scientific notation, so we're on the right page now. There are a few notes that we need to keep in mind for what scientific notation looks like, okay? So scientific notation is some number. It can be a decimal. It doesn't matter. So we're going to say A. It's just some number, okay? Now, I'll describe a little bit more about that number here in a second, but it's always multiplied by something that is base 10. Base 10. It's always, always, always base 10, okay, to some power. Okay, so for example, some examples that you might see is 3.1 times 10 to the second. That is scientific notation for that number. Or 2.008 times 10 to the negative 12th. Okay, 6.23 times 10 to the 23rd. Okay, types of numbers that you might see is all I'm trying to show you there. So there are some rules for what this sum number has to be. This number here, it has to be less than 10. Okay, it cannot be a two-digit number without a decimal separating it. But it also has to be greater than or equal to 1. Okay, so it has to be less than 10, but greater than or equal to 1. So what I say is move your decimal until there's only one digit left to the left of it. Okay, so move your decimal until there's only one digit to the left of it, and that will be a pretty solid rule for you. Okay, so here's the rule for what that sum number can be up front. So we're just going to get straight into examples. Y'all guys should have seen this before. Have y'all seen this scientific notation? Okay, good. So I'm just going to get straight into examples then. We have 856,000, and we need to convert that to scientific notation. So, like I said, put your decimal where there's only one digit to the left of it. So we're going to have 8.56. These zeros are non-significant digits, so we don't need to include them. Okay. Now I ask myself, we're always going to multiply this by base 10. How do I get back to my original? So when I say how do I get back to my original, I just count the spaces. 1, 2, 3, 4, 5. So I get back to the original by going 5 spaces to the right. So make this little note. Right stays positive. Left goes negative. Okay? So I think left as less, so that helps me remember negative, and then right just goes with it because there's only two options. Okay? So I always think left is less. So on B, we have 0.1, 2, 3, and then 5. So 0.0005. And again, I want to move my decimal until there's only one digit to the left of it. It's non-zero. One non-zero digit to the left of it. So it's going to be 5, just 5. You don't have to put 5.0, times base 10. And then I ask myself, how do I get back to my original? I go 1, 2, 3, 4 spaces to the left. So left is less. So I'm going to put a subtraction or a negative symbol there. And there we go. Questions so far? Okay. This gets kind of compounded quickly, so if we have questions here, we need to get them answered. Anything? All right. Example 2, they go straight into multiplying things. Now I want to remind you, when you're multiplying things with like bases, like a to the m times a to the n, what do you do with their exponents? Add them. Good. So when I'm multiplying things of base 10, I'm going to do that same kind of concept. So here we go, 5.7 times 10 to the 5th, and then that gets multiplied by 1.8 times 10 to the 3rd. Now they have these in parentheses, but why is parentheses unnecessary here? Because they're not negative numbers. Yes, that's one reason. Also, these are commutative. Multiplication's commutative, right? And associative, so the parentheses aren't necessarily useful here. It's just to remind you that these two go together and these two go together. But since they are commutative and associative, I'm going to use that property to switch these two. Okay? So the commutative property allows me to do this. So it goes 5.7 multiplied by 1.8. Whoops, 1.8. And then I'm going to put those in brackets. Again, they're associative. Okay? So I'm going to multiply those two together. Next one, since I moved my 10 to the 5th, it's going to be 10 to the 5th multiplied by 10 to the 3rd. Okay. Now I start to combine the things that I know how to combine. So I can multiply 5.7 times 10.5 gives me, I think, 10.26 or something of that nature. 10.26. So these two multiplied by each other gives me 10.26. Now I'm multiplying like bases, so what do I do with their exponents? Add them. So it's 5 and 3, which make 8. Good. And these are still multiplied together. Remember, we keep our signs. Okay, keep our property that. And what am I trying to say? Our operation. There we go. Keep our operators. Here we go. So it says 10 to the 8th. If it said put this in standard form, okay, standard form, I would go ahead and multiply this 10 to the 8th out, and I would move it 8 times. I would move my decimal 8 times to the right. If it said standard form is just regular number, no base 10. Okay. Is this in scientific notation? Right here. No, because why? Right. Because there's 2 digits to the left of this decimal, right? So it doesn't follow our rule where it has to be less than 10 and greater than or equal to 1. So I need to move this. So I need to put my decimal here, right? So how do I get back to my original? I move it 1 to the right. So since it's 1 to the right, that's positive. Remember, positive is the same as plus. So I'm going to rewrite this 1.026 times 10 to the, since I moved it 1 to the right, I'm going to add 1. So now it's 10 to the 9th. If I had moved it to the left, I would subtract 1. Questions there? Okay, so where we had this note, we said right goes positive, so maybe we'll make another note that says add, and left is subtract. Okay. Questions yet? Okay, example 3. Dividing. So what do we do when we divide things with like bases? We subtract them. So on this case, it would be a to the m minus n. So that's your little side note. On this problem, it says 1.2 multiplied by 10 to the 3rd over 9.6 times 10 to the 6th. I don't know why I put an x. Try to avoid writing x's in there. I know your book does it. The reason we avoid that is so that we don't confuse them with variables. Okay. So again, we have like bases, and we said we subtract our exponents, right? So if I move this up here, it's subtract 6. Okay. Now I need to deal with this 1.2 and 9.6. So I just divide it. If you're going to use your calculator, that's fine. 1.2 divided by 9.6 gives you 0.125. So here we go. 0.125 multiplied by 10 to the 3 minus 6, which is negative 3. Okay, so I just subtracted my bases and divided these two right here, just like it told me to. 1.2 divided by 9.6. Okay, give me 0.125. That's not scientific notation. I need to move my decimal right here. So I'm going to go ahead and rewrite that 1.25. Now that that's in proper scientific notation, I need to adjust my base 10 to go back to what the original would have been, which would have been 1 left. So that's less 1. So it's 10 to the negative 4. Questions? We're going to combine all this in the next one. So, questions now? Okay. So we're going to do example 4, which is a comparison of these two things. We're going to try to use both of our properties. 7.2 multiplied by 10 to the 6th over 3.6 multiplied by 10 to the 4th. Now I'm going to leave a big space here because we're going to end up comparing these with a less than, greater than, or equal to sign. And that leaves me a little bit of room to work. Okay. Then the next one is 1.05 times 10 to the 7th over 3.5 times 10 to the 5th. Okay. Working from here, I'm going to do the left side first. I'm just going to ignore everything on the right for the time being. I'm just going to do the left side first. So I take my two numbers that are just regular, not my exponents, and I go ahead and divide them. So 7.2 divided by 3.6, and it gives me a solid 2. Okay. Then I take, so that's gone. I'm done dealing with that. It's at the 2. Now I need to take this and I need to move it up there, so it becomes subtract 4. So 6 minus 2 is, or sorry, 6 minus 4 is 2. So it's just base 2. Is this scientific notation? Yes. So if I was leaving it in scientific notation, I would leave it right there. However, I'm going to compare these, so I want to write them out in full form. So this says move your decimal place 2 times. So here's my decimal place, move it 2 times, fill those in with zeros, and I get 200. So everything on the left is equal to 200. So I'm going to compare that to whatever I get over here. I'm going to make that just a little bit bigger so it doesn't look like another 0. I'm going to compare it to whatever I get over here. So I'm going to take 1.05. I'm going to divide it by 3.5. I get 0.3. So 0.3, that's taken care of. Now I'm going to take this, I need to move it to the top so it becomes subtraction. Oh, I keep writing the answer instead of the number. Minus 5, I'm sorry. And then I get multiplied by 10 to the second. If I want to convert that to proper scientific notation, I would have to move my decimal 1 place and change that. But that's not what it's asking us to do. It says compare. So I'm going to write this in proper standard notation. So it says move your decimal place 2 times. 1, 2. Fill it in with a 0. We get 30. So 200 is greater than 30. Remember, we always open towards the larger side, and we point at the smaller one. Questions yet? Okay. Example 5. Application of light and speed. These are the ones that are actually more interesting. Yes, you are dealing with larger numbers, but consider it like a smaller number first if you get confused. Okay? So I'll explain that a little bit more as I go through this example. It says the speed of light is 3 times 10 to the 8th meters per second. So meters per second. If the Earth is 1.47 times 10 to the 11th meters from the sun, how many seconds does it take light to reach Earth from the sun? Write your answer in scientific notation. Okay, so how many seconds will it take? So we want to think about this as a smaller problem. So here, this is a rate, right? This is our speed, and this is our distance. So if I want to think this as a smaller problem, if the distance from here to Roswell is, I know it's not, but let's just pretend. Say it's 120 miles, and you can travel 60 miles per hour. How long is it going to take you to get there? How did you find that? 120 divided by 60, right? So we took what? We took our distance and we divided it by our speed, right? So if this is our speed right here, if this is our speed and this is our distance, I'm going to take my distance, 1.47 times 10 to the 11th, and I'm going to divide it by my speed, which is 3 times 10 to the 8th. And then that ought to give me my answer. Okay? So I do it just like I did the last ones. I take 1.47, I divide it by 3, which gives me 0.49, and then I take, so that's dealt with. Then I take this, and I need to move it up top to combine it, make it into scientific notation. So it becomes 10, base 10, and then we have 11 minus 8, which makes 3. Okay? Putting this in proper scientific notation, if that's how they want you to express your answer, we need to move this decimal to right here so that there's only 1 digit to the left. Then I have to ask myself, how do I get back to the original? I go left 1, so I'm less 1. So the proper scientific notation is 4.9 times 10 to the second. Okay? Then I need a label if it is meters per second, and the question asks us to write our answer in scientific notation and to find the amount of seconds. Our label will be seconds. So 4.9 times 10 to the second, which is 490 seconds total. Okay, but told you to write your answer in scientific notation, so here it is. 4.9 times 10 to the 2. to explain a little better of what scientific notation is used for, it's for representing really, really large numbers and really, really small